Hi, everyone. Welcome to our webinar. Thanks so much for being here. Before we want to launch in, we just want to ask you guys a quick question about where you're logging in from. We know that this webinar has been specified for teachers in New York, but we're sure some of you are outside of New York. So if you fill out this quick poll, that'd be great, so we can start getting a sense of where everyone's coming in from. Ooh, there's a lot of upstate New York. Wow, 75% upstate New York right now. Ooh, 13% New York City. That's pretty good. 22% outside of New York. If you're logging in from outside of New York, feel free to write in the chat box and say where you're coming in from. We'd love to hear it. Okay, about 75% of you guys have voted, so quickly put in your answers if you want to be represented here. Maybe, that'd be great. If anyone's just logging in and joining us now, we know we're right at the top of the hour. If you'd fill out this poll, we're just getting a sense of where everyone's coming in from. We acknowledge that this webinar was focused on New York teachers. It totally applies to all teachers. So we would just love to hear where everyone's coming in from. Okay, great. Awesome. Cool. So we can share out results. You want me to do that? Yeah. So we have a lot of people from upstate New York. That's great. We're super happy to have you here. A few people from Long Island, a few more from New York City. Hello to everyone in New York City. No one in downstate New York. I'm not from New York, so I don't really know all these regions all that well. And it seems like we have a good amount of people, about a fifth from outside of New York. So that's fantastic. Thanks so much for logging in, guys. Cool. So I'm going to go ahead and share my slides now. Let's see how I do. Okay. Does that look good? Yeah? Maybe? Kate?
Yes, it looks great. We can see it.
Great. That's what I like to hear. So everyone, welcome into Sparking Student Interest with Greener Chemistry webinar. We are thrilled to have you guys all join in with us here. Today's discussion is focused on how green chemistry and sustainability fit into the New York classroom. We're thankful to have support from New York Pollution Prevention Institute in supporting this webinar. Together, we're teaming up to build a community of K-12 green chemistry educators in New York. Additionally, New York Pollution Prevention Institute is supporting New York teachers with full scholarships to our online course. So be sure to check that out. We'll talk about that a little bit later as well. We're happy to have Annette and Jim coming in from Gunderlin High School and Canton High School, both New York teachers, both New York master teachers, and lead teachers with us here at Beyond Benign. They are the perfect panelists for insight on how green chemistry fits into the New York classroom. This webinar will be recorded and all attendees are in listen-only mode right now. So if you have any questions, please feel free to put them into that chat box and we'll get back to you. Awesome, thanks. So who am I? I am Janie Butler. Welcome into our webinar. I'm the K-12 program manager here at Beyond Benign. We are a nonprofit organization that focuses on green chemistry education. Who is Beyond Benign? What is our mission and vision? Our mission is to foster a green chemistry education community that empowers educators to transform chemistry education from cradle to career for a sustainable future. And the way we see this happening is that we want to envision a world where the chemical building blocks of the products that are used every day are healthy and safe for humans and the environment. If you'd like to continue to stay engaged and involved, please sign up for our newsletter. You'll see the link to that over in the chat box to be notified about upcoming webinars and opportunities in K-12. We also have resources for colleges and universities and professional education. And if you like what you hear today and would like to contribute, please do so by donating on the link on our homepage. So I've been saying the chat box a lot. Who's manning our chat box? Big thanks to Kate Anderson, our K-12 Director of Education, who will be talking with you guys over on the chat, collecting your questions. Also, if anyone engages in social media, we would love to connect with you there. We're on Twitter, Facebook, we're also on LinkedIn and Instagram. You can see our connections here. Please use #GreenChemistry if you'd like to share out. And additionally, if you have any questions, please feel free to submit them during the course of this webinar. Awesome. So we're going to jump into our webinar, but before we're going to launch another poll. So thanks so much, guys, for responding to that other poll to gauge who's on the line with us today. So let's launch this poll so you can tell us a little bit about yourselves and we can get a better sense of who's the audience in the conversation with us today. Cool. Whoa, we have 100% high school chemistry teacher. Oh, it's quickly dropping. More people are responding. Okay, yeah. Oh, if you're in the other category, we would love to hear from you on what other is, what you do, if it's outside of these groups, and maybe why you're interested in green chemistry education. Okay, I'll give you a few more seconds to fill it out. Hopefully there's no errors or technical difficulties for anyone on doing this. Sometimes you have to exit out of full screen to be able to answer the polls. So hopefully it's working for everyone. We really like being able to gauge who our audience is so we can know who we're talking to. Great. Okay. I think that seems pretty good. I'm going to close the poll now, and I'll share out the results with all you guys too, so you can see who's in the audience with us today. We have a lot of high school chemistry teachers, which is fantastic. A few other STEM teachers, a few informal science educators, welcome, welcome everyone, a middle school teacher, and then some people who are in the other category. So that's great, really. We love to see people from different spectrums of education. We do work a lot with high school chemistry teachers, so we're excited to see that a lot of you have logged on to join us. Great, thank you. So let's get into our presentation. I'll go to the next slide. Hopefully you can still see me. This is a bit of the flow we're going to be going through today. So 3 big categories. First, we're going to be focusing on the problem. Why are we talking about green chemistry education? Why is there a need to change anything in the traditional science classroom? What are the tools that can be used? What does Beyond Benign offer? And also, what does New York Pollution Prevention Institute offer as tools for K-12 educators in order to implement sustainable science in their classroom? And finally, hearing from Annette and Jim on what does this look like in the classroom? What is the practice of this? And what does it look when it's being used in an actual New York classroom? So first, we're going to hear from Annette a little bit. She's going to talk about the problem, what it was like in the science classroom when she first started to learn how to teach. And first, we're going to just learn a little bit about who is Annette. So Annette, if you can turn on your webcam and your audio, we'd love to hear from you.
Hello, folks, and thank you for joining us. I am Annette Sobuyera. I'm a veteran teacher of Guilderland High School. It was my first job. I have been teaching for 28 years, and in that time, I have grown as a chemistry teacher, and I began to embrace the greener ways of teaching chemistry. So if we go back on the slide before, and I want to explain about what the problem is. Chemistry is a discipline that has been taught over so many years. And so what we deal with are the labs that were created way back when chemistry was instituted into schools. And some of the materials that were used were always hazardous. So now we are dealing with someone giving us tools to make these labs greener. So most of these labs, what I have found that works is that we do not have to use the hazardous materials that were implemented in the previous labs in order to maintain the chemistry skills that our students need, and also to make observations of the outcome of what the experiment was calling for. So what's missing for most educators are the tools on how to go from what you have been using to adapting it to a greener way. So hopefully after today's presentation, you'll be able to take some tools with you that will be able to spark your students' interest in chemistry. Back to you, Janie.
Awesome. Thank you so much, Annette. So I'm asking you guys a lot of polls today, and I swear maybe it'll stop soon, but I have one more for you guys right now. We've been talking a lot about green chemistry, and I just want to gauge the interest of everyone here on what is your knowledge of green chemistry. So we have a little bit of information here. We'll go back to that, but is it your first time hearing about what green chemistry is? Have you heard of it, but you're not really sure? Do you use some sustainable practices in your lab, or are you teaching it to your students? Do your students know what the term green chemistry is? Do they know the practices? Anywhere on this spectrum, we just love to hear where people are at, so we're able to also speak towards that and understand our audience a bit and welcome you guys in. So it seems like we have about half of the group that have heard of it but not totally sure, which is honestly one of my favorite spots because I feel like that's great. We get to share out a little bit of knowledge and share that with you guys. So we can also, yeah, now you can see the results. Great. So a few of you, it's the first time hearing it. A few of you teach it to your students already. And then most of you are right in that middle ground of using some sustainable practices in your lab or not really sure what it quite is yet, but you're interested. So all the more, thank you so much for joining us, especially if you're in these groups, because you're really taking a leap of faith of wanting to learn more, and that's fantastic. So thank you, thank you. So what is green chemistry? This is the definition of it. It's the design of chemical products and their processes that reduce and/or eliminate the hazardous substances. Now that's a little wordy, at least for me. I think that can be hard to digest. So an easier way to break it down is benign by design. So creating things, doing things in certain ways that are more benign or better for the world in the way that they were designed to be. So thinking about sustainability at that very first step. And green chemistry is made up of 12 principles, but we like to boil it down into 3 main categories of cost, safety, and performance. Safety refers to the safety for both humans and the environment. Is it something that's going to be toxic once it has waste? Is the disposal going to be really nasty? Is it going to be hard for students and teachers to use? Or is it going to be more safe? And so we want to have a really high safety rating on everything we do in green chemistry. The second is performance. How does it compare to the traditional labs or traditional innovations? It has to be able to perform at that same level or better. The final one is cost. If something is really safe and performs really, really great, but is super expensive, it is not viable. And so it has to have a low cost. So I like to look at this image and see the blue and the yellow. I think those two have to overlap a lot to make a lot of green and have very little red, very low cost in order to make that green chemistry. So without having all 3 of these criteria, it is not green chemistry. It needs all 3 to come together. And like I said, this is built off of the 12 principles of green chemistry, just to boil it down into these big criteria. So who are we? Who is beyond benign? Why do we talk so much about green chemistry education? Well, as I touched upon before with our mission and vision, we are a green chemistry education nonprofit. We want to be able to share green chemistry with more teachers and educators from the K-12 and higher ed levels. So what we do is we create a lot of experiments that there's labs that replace traditional labs. There's new experiments where you can teach your students about sustainability. And from there, we like to have workshops and trainings where we teach different teachers and educators about how these can be used in the classroom. Thanks so much for joining us today on our virtual webinar where we're doing one of these like that. We also try to cultivate a community of future leaders. So of teachers who want to be doing more work like this, who care, who have passion for green chemistry, and also of students who understand the importance of practicing sustainable science. And the way that we see this happening is really that green chemistry in K-12 is at the center of it all, that this can percolate outwards and have students who have learned about green chemistry at the K-12 level asking about how their labs can be done more sustainably at higher ed, or when they're in the industry level of how can this be done better. We also understand that a lot of your students probably won't be chemists or won't be in the STEM field. They'll be doing something else. But if they're students who understand that, maybe science and sustainability, there's more overlap there than I originally thought, they can then be consumers who ask that of their products or who understand that maybe those chemicals aren't the best or are curious in what makes up what they use. And so our hope is really to get to that bottom rung of sustainable human health and the environment to make some real lasting change. So we really think that K-12 education is important. It's at the center of making this huge change around the world. So going back into the toolkit, how does this break down into tools that you guys can actually use directly into your classroom? So a few of the things that I mentioned before, is that there's the experiments that we have online. We have over 200 labs that are ready to be put into your classroom. They're in Word documents and NGSS aligned, so we're trying to make it as easy as possible to just be put in. You guys can also modify it and make it adapt to your classroom by having it in those Word documents. Also, everything we do is made by teachers for teachers. So we love having you guys as part of our community, getting feedback from our own teachers of what's needed in order to make real change in the classroom. We then do different workshops and online trainings. I touched upon this before. We have an online training during this summer, an online course that you guys can take for high school teachers if you're interested in learning more about this. And the big part is that we have this community of green chemistry change makers. And so I would really love to welcome you guys in as part of it. And it's through this community and through these experiments, everything that's online, through these trainings that we're able to make big change and give you guys the tools to make these changes. So that's all from Beyond Benign. I'd encourage you to check out our website to learn more. There's also information and resources that New York Pollution Prevention Institute offers for you New York teachers. So here's more information about the Clean Sweep. You will apply, you can get your district assessed and have some chemicals taken out. So this way, when you're ready to use safer, greener chemistry for your students, you don't have to worry about still having those nasty old hazardous chemicals in your labs causing harm. So I'd encourage you guys to check this out too. Thanks. So we've gone over the problem. Annette did a really good job of outlining what happens in the traditional science classroom, how that can be a little bit concerning for both teachers and students. We then went into the tools that Beyond Benign offers and that the New York Pollution Prevention Institute offers for you K-12 teachers. And finally, we're going to go into what does this actually look like in a classroom? Tools and understanding the problem are great, but we need to know the practice of it. How is this possible? What does it look like? And so for that, we're really grateful and lucky to have Jim and Annette joining in and sharing how it looks for them in their classrooms in New York. So first, we're going to hand it over to Jim, and he's going to share who he is, what his perspective is, and how green chemistry fits into his classroom.
Good afternoon, everyone. I'm Jim Burdick. I teach high school science in Canton, New York. It is in a region that maybe doesn't fit perfectly into those polls. I have to find when I travel outside New York, I have to describe it as Canton is in very northern New York. When I go to conferences, and some of us maybe here from my region have gone and been called Southern Canadians with me, that kind of gives you an idea of where I am in the state. Besides my work with Beyond Benign and the Master Teacher Program, I also do a bit of volunteer work with the Adirondack Mountain Club, and I'm an EMT firefighter in my local departments, which explains why my facial hair looks like this. It doesn't normally. I had to make sure that the N95 mask could actually fit on my face as I'm riding around in the ambulance. So on the next slide, I wanted to share quickly how I became involved in all of this and with Beyond Benign. And it started with somebody just simply mentioning Beyond Benign existing to me. And that led me down this whole path of opportunities I had never heard of before. So I looked up Beyond Benign. I ended up signing up for the green chemistry online course. And that same summer, I went to the biennial conference on chemical education and kind of in person discovered Beyond Benign. I discovered Twitter at the BCCE. It is apparently really fun. I didn't know that. Students love it when I hashtag everything, and sometimes they hate it, but I love it anyway. So follow me on Twitter. I think my Twitter thing was somewhere on there. Later that same summer, I took that little tiny 8-seater plane that you can see on the screen to Boston for the ACS national meeting. And based on what I had already experienced with Beyond Benign, I totally reconfigured my schedule at the ACS meeting to find more green chemistry things. Like Annette, I was finding that I was being given old tools to use in my lab, old labs that weren't really that safe, created disposal nightmares. And these two conferences and getting oriented to Beyond Benign totally changed how most of my year is run. So can we go to the next slide, Jamie? most of what I want to share today with you surrounds using phenomenon in your classroom, and how I've taken some of the Beyond Benign labs on the website and kind of broken them apart, not use them as paper pen labs, but as phenomenon in my classroom to drive inquiry. And that's one of the things we have to remember with using phenomenon is we're using them to drive student inquiry. We have tons of ways of visually impressing students, but we can't just do something like elephant's toothpaste and yell the word catalyst and exothermic and call it a day. We have to use those phenomenon to drive student inquiry. You shouldn't be the one explaining the phenomenon. The students should be investigating, asking questions, trying to describe it for themselves. So there's 2 links on the screen there for other really great resources. There's Paul Anderson's website, The Wonder of Science. There's tons of phenomenon on there. There's, I think the document is called the Master List. And there's a lot more ideas at the second link. You can probably just Google 3D Science Cafe and you'll get a lot of 3-dimensional learning ideas on there. So I think, can we go to the next slide? So one of the ways, one of the first labs I want to show is using catalase to decompose hydrogen peroxide. But not just straight up catalase, using it from like a piece of liver or a potato. And I wish I had a video of this because it's really cool. You can take that little bit of liver, put it in a test tube, have the students put a few drops of just normal 3% store-bought hydrogen peroxide on it, and they'll see all sorts of bubbles come out. After a while, they can also start to feel it get really, really, really warm. So you can even go so far as to do like a splint test with it. You can get students asking questions. They'll start to wonder, like, is this the same thing that happens when you put it on a cut? Because it's the same liquid. Would their liver have the ability to break down hydrogen peroxide? You could have them do different test tubes with things you know will break down hydrogen peroxide and things that you know won't. And so they can start asking, why would these things be able to break down hydrogen peroxide and these other things won't? So I took this reaction from a lab on Beyond Benign's website called Catalyst and Oxygen. It also appears in the lab on the next slide called the Endothermic Exothermic lab. You can also break apart this lab and use them as phenomenon instead of just a paper pen lab. You could even quantify the heat if you wanted to. The difference is large enough to do a calorimetry experiment on. For the exothermic reactions, liver isn't the only thing that'll work. Potato will work too. You can use crushed up vitamin C pills, not like the Emergen-C tablets, but like actual vitamin C tablets, or just normal old yeast will all get these bubbles going and produce the same thing. This would replace something like dissolving sodium hydroxide in water or using metals and acids, both exothermic things, but you can do it in a bit of a neater way with like bits of liver and get the students working with like how many times do they get to cut up bits of liver at school. You can get the opposite reaction in the endothermic process just by dissolving citric acid in water. And you can get that from something they know like pixie sticks or Fun Dip. There's tons of citric acid in there, and when you dissolve it, they'll feel it get cold. And as a follow-up afterward, when they have that citric acid solution, have them throw baking soda in it. You'll get bubbles from that as well. And then you can have the students compare splint test results, have them asking questions about that. What is the gas? Is it breaking down the same? Are they the same process or are they different ones where you have different temperature changes? It's all very, very, very flexible, and you can pull these things apart and fit them in wherever you need to in your year, basically. And replacing things like working with the barium hydroxide and ammonium, you don't have the disposal concerns with those. Who cares if a student mixes baking soda and hydrogen peroxide? instead of whatever other chemicals you might have given them from a lab that was created in the 1960s. It's all going to go down the drain at the end of the day. It's much, much safer. So these are the two labs. The titles are on the next slide, as well as a link to where you can find them. So you can navigate right from Beyond Benign's homepage, or you can follow this link right to the high school resources. The two labs that have those processes in them are the exo and endothermic reactions and the catalyst and oxygen lab. Again, pull them apart, use them as phenomenon, get the students asking questions, and you can take those paper pen labs and have some sort of three-dimensional, I guess, jumping off point, at least from those that's a bit greener than ones you might find just by Googling them. So after the students explore this, investigate this, and come up with their explanations, and we refine those explanations to fit what's actually happening, then go and impress them. Then go and do the giant elephant's toothpaste, like on, I don't know if anyone saw Miss America do this recently in the past couple of years. Did this huge, gigantic elephant's toothpaste on stage, and at the same time, she's teaching how a catalyst works and what the reaction is. But when you're going for this big, impressive thing and you're teaching the students what's happening yourself, how many people watching that Miss America video remember what she was teaching about? I think most people are just going to remember this big foamy pile of stuff, not the actual chemistry behind it. So use these phenomena to drive the student inquiry, have them come up with the explanations, or at least lead them through it, and then impress them after. Doing the big impressive thing beforehand, how much are they gonna remember of what you're explaining, and instead just the big foamy stuff? So again, these are super flexible. Can we go to the next slide? There's other possible related labs that you could pull apart and use as phenomenon instead. Or you can use part of it as a phenomenon and then the rest as paper pen lab. I won't dive into this one too much, but you can find the chemical or physical reactions lab. There's 11 processes on there for students to determine if they're physical or chemical processes. Take a look at them and see if there's anything on there that you could replace in your classroom where you currently have them look at chemical or physical change, and see if there's a greener way in there that you can change, you can implement in your classroom like right away without even having to teach the students what are the 12 principles. There are things you can do on the back end to get your labs a bit greener. So you might, around the same time in your year, be doing types of reactions. Googling as a green chemistry person types of reactions demos is like a huge dread, because you will find tons of things that are either just disposal nightmares or huge safety hazards. They might look really, really, really cool, but give you that extra worry on top, like, how am I going to get rid of this? You know, what do I have to tell the kids to be safe with this? And there are green versions that give as dramatic of a change, but don't have those hazards and disposal considerations with them. You'll hear, Janie mentioned earlier the Clean Sweep program. I think later it'll be described a little bit more too, maybe. But if you don't make that disposal hazard in the first place, or you don't use it in the first place, it's not a worry. If you're someone who knows what the 12 principles of green chemistry are, the first one is prevention, and it's the first one for a reason, because it has the biggest impact. If you never use it, you never have to worry about it. So some of the most ungreen types of reaction demos are for the double replacement reaction. So on the screen, what you're looking at are two different versions, two different double replacement reactions. And what the types of reactions lab on Beyond Benign's website would have students do is compare the two possible reactions, analyze them for the 12 principles of green chem, or you can even just have them research the safety data sheets. And they have to justify which one they're going to perform when they actually do the lab hands-on as far as safety and green chem goes. So you could go a step further and not just have them do it on paper pen, you could be doing this as a whiteboarding session, talk about NGSS and arguing from evidence. They're using SDS and the 12 principles as evidence to argue why they would perform one of these reactions over the other. And then they'll actually go and do it. So there are people I know that do this lab exactly as written. There's people that take it and do whiteboarding with it, or have the students justify beforehand why they're going to do it. And I think that would be the point, is they're actually thinking about these reaction types, or thinking about what they're about to mix and what they're going to make and how safe it's going to be before they do it. And they have evidence for why they're not doing something else. And that's what chemists do, is they try to think about it ahead of time so they're not going to have some sort of nightmare to deal with. Gives them some insight as to why we have lab rules. They'll be actually looking up the reasons for it. So you've probably by now had time to read it and maybe choose which one you would do. I'm looking all day long at choosing procedure 2. I think there's a box that will magically appear in a second, maybe. Pretend there's a giant box going around procedure 2, because that's the one you should be picking as far as safety and disposal greenness. Calcium chloride, generally considered safe. Sodium carbonate, generally considered safe, versus copper sulfate and potassium carbonate. With procedure 2, it's not going to give you like the bright yellow as using the potassium iodide double replacement, but you still get a dramatic change from clear to white, and they'll see the solid forming. It's still a dramatic change. It's just not that brilliant yellow, and you don't have the disposal considerations to worry about. So can we go to next one? Oh, did we skip a slide? Or no, I guess not, sorry. One of the types of reactions labs I like to have my students actually do as more of a cookbook lab is the copper cycle lab that the New York State Pollution Prevention Institute actually published a while back, with the help of the person who actually mentioned Beyond Benign to me in the first place and was my ACS science coach at one point in time. If you Google copper cycle labs, some of you might use this. It was one of those labs that was kind of provided for me when I started teaching chemistry, one of those old tools that I didn't know there were newer versions of. They'd have students using things like 6 molar or larger sodium hydroxide solutions, concentrated nitric acid. If anyone's familiar with Ira Remsen and his writings, that was the acid that he found reacts with fingers and pans. It's not something I want my students working with in my lab, because I know there are other versions now. These other versions, on the next slide, you'll see the 2 cycles that this lab uses. As it's written, everything uses 1 molar solutions or even less. Nothing's super concentrated. There are acids in it, but they're not concentrated. It's a little bit more manageable for the students to be using without crazy safety worries on your part. You still get dramatic changes. You still get dramatic blue foamy stuff and the clear to blue, and you get all the changes you're looking for, but it's a lot safer. This lab takes about 60 to 80 minutes, something like that, and you can stop it at certain points, leave it in a drawer, come back to it later if you have shorter lab periods. My science coach and I have been working for a little while trying to figure out quicker ways to get it done, or at least one side of it done if you have shorter lab periods. But that's out there. You can find it on Google or on the link on the previous slide. So there are these new versions out there that update these old tools that a lot of us have just been given, and they're a lot safer, they're a lot greener. You don't have the disposal nightmares that some of them have. And just because you find a lab as it's written online or on Beyond Benign's website doesn't mean you can't pull things apart, use them as phenomenon to drive student interest and inquiry instead of just as a paper pen lab. Everything everything I've shown on the next slide, I went through the New York State Science Learning Standards, which are basically just the NGSS with New York's twist on it, mostly about the same. Everything I talked about has to do with the standards on the screen there and the three-dimensional learning ideas I've bulleted out there. It's just a matter of how you use them and whether you're using it as an impressive magic show or to drive the student inquiry. And you can find any old lab online, pull something out of it, use it in that way instead of just as a cookbook lab. So that's a few examples of how I've done it with Beyond Benigns labs. If we have time, I can take any questions right now, but that's all I wanted to show. Or are we going to do questions at the end? I don't know.
You can check in with Kate for Jim.
Are there questions now, or are we waiting for the end?
I don't see any questions right now, Jim, but we'll give people a minute to kind of think things over. We did get an interesting commentary.
It was a lot all at once.
Yeah, and we actually additionally got a resource that is shared by one of our teachers who's tuning in from the UK. So I'm gonna share that with everybody in the question chat box. So just as a reminder that you can go ahead and fill in questions, or even if you have additional comments, you can put it in chat or the questions, and then we can share it out with everyone. So thanks.
Thanks so much, Kate, and thanks so much, Jen. As you guys start having more questions, feel free to put those in. We will circle back at the end to go through all the questions all together. So now we're going to hand it off over to Annette, who we heard a little bit from already, but hopefully we'll hear a bit more from her now of what it's like to have green chemistry in her classroom.
Hi again. So as from my title slide, to tell you a little bit more of what I do in the classroom. So when I was thinking about doing this webinar, I wanted to share with you what we were about to do in my classroom, and then we ended up closing. And so something to show that the labs are really green, I was able to run the labs right in my kitchen and have the students observe and take data and be able to do an analysis. So you can see on my slide that I have been with the Master Teacher Program. I'm National Board Certified Teacher. I'm a lead teacher with Beyond Benign and participating with the ACS and also working with the Science Coach. So on the next slide, I want to share with you how it is that I make a decision to have a greener lab. So what I want to let everyone out there know is that there's no need to start over. If you have your list of the labs, you just have to take what you have now and then just try to make it work with a greener way. And why do you have to resources that are available, and the location of where we can perform an experiment is changing. So there isn't a better way to get you implemented into greener labs than the present situation. And before you embark on any lab, the questions to ask is, why does this experiment demonstrate? How does it fit into the lesson plan? Is it interesting? Does it work with your students? And then, of course, most importantly, do your students have the skills to succeed? So in the next slide, you will see how, in responding to this, so I just wait for the next slide. Is the lab worth running? And if the lab is worth running, consider the following. Are the reactants safe? Meaning that do they have a less hazardous outcome? Are they sustainable? Are the products safe? Can you safely dispose of those products without endangering the environment? How much waste is produced? Are you excessively using the amount so that you produce more than enough of what you need? And what will I have to buy? How accessible can you get to the materials that you need for the lab? And then how much of it will I need to store? And by talking about the storage part, you need to take into consideration the safety and the sustainability of these reactants. So on the next slide, I'm going to share with you one of the labs that I have done in my kitchen, and it's also what we would have done in the classroom. And so towards the closing of our school in March, we were starting the unit on the equilibrium. And so I'm going to share one of the labs, which is a Le Chatelier's lab, and I'm going to explore the effect of temperature and the effect of concentration, both changes affecting the point of equilibrium. This lab is also accessible on the Beyond Benign website. All of the NGSS that are met in this lab are the ones that Jim listed, plus one more of the PS 1 through 6. And so if we click on the form there, so I can show what the lab looks like, please, Janie.
Yeah. All
Do we have a copy? Do they have that in their chat box? Do they have the copy of the lab in their chat box?
yes, they will get that in the chat box. Get their own resource to it.
Perfect. Right, so in this lab, you will have that in your chat box. You will see how students have the data table in front of them, what it is that they have to supply, how much information I provide, and how successfully can they complete the lab by taking observations. So we're going to share a little video with you. And so just past the greeting, I informed the students of how we are going to perform the Le Chatelier's lab and be able to show how by changing one of the conditions of the experiment. So the first one is the effect of temperature. In the left beaker, we have some ice water, and in the right beaker, we have some hot water, and I think you guys are seeing it the other way, the opposite. And we have homemade liquid starch, which we are going to use as part of our solution. Liquid starch is a clear solution, and taking 2 squirts of it, adding some water, and then anyone from biology remembers that you can test for the presence of starch by adding an indicator. And so that indicator is iodine. And so that's betadine. It's the iodine tincture. It's right out of my bathroom dresser. And by adding a little bit of that, you get the deep blue color that is the one that we use to identify and confirm the presence of starch. This solution is then placed into 3 test tubes. One is going to be the control, which we are going to leave in the middle, and the other 2 are going to be placed in different temperatures. One of the test tubes will be placed in cold water, and the other test tube will be placed in hot water, and the middle test tube is left as a control. The hot water was at about 80 degrees Celsius, straight out of the tap. Water, the ice water, was at 0 degrees Celsius. And what I wanted the students to see is to be able to take observations of what had happened after the 2 test tubes had been placed in the different temperatures. So here come the results. You can see that the hot water turned clear. And so by looking at the equations, the students can see which direction the reaction shifted. And then you can see that the one in the cold water has turned a darker color. And so I only show what has happened. I do not say it has turned darker or it has turned clear, but I do discuss what the temperature is, and I do remind the students of what the control looked like in the middle. And so by being able to look at their lab, they'd be able to figure out what shift was caused by the decrease of temp and what shift was caused by the increase of temp. The second part of this lab was the effect of concentration. So we can look at that little lab and just see what we implemented. So you can click on that one. Okay, so in this time, we're going to check for a change in concentration. And what I end up using in this part is butterfly PT, which is one of the teas that are out there. If you go to one of the tea places, you'd be able to have some of that. And when you brew this tea, it has a really nice color, almost a purple. Okay, so it's called butterfly PT. Again, I'm going to place it in 3 test tubes. Going to keep the middle one as my control, and I'm going to change the concentrations. Now, as we know, tea with its tannins and its acidity, you can control and manipulate the amount of acid by either adding household vinegar or lemon, what you have at home, and also removing some of the acid by adding household ammonia. And so to one test tube, we're going to add vinegar, and to another test tube, we're going to add household ammonia and look for the changes, comparing them to the control. So add a few squirts of household vinegar. And then in the other one, add a few squirts of ammonia. And you have the students take data, and they can then work with finding out which direction the equilibrium shifted by increasing the amount of acid or by decreasing the amount of acid by adding a base to it. So simple labs in your household, visual enough for students to be able to make an analysis and a conclusion from a lab, such as a Le Chatelier's lab. So that was a lab that I wanted to share with you. Some instances, there's some matters which you cannot test at home. There's another section of this lab that tests the effect of pressure on chemical reactions. I did not have a pneumatic tube in my house, so that way we just went online and watched a YouTube on how pressure affects an equilibrium. It was not of this reaction. It was for the N2O4 NO2 equilibrium. Next slide. And I hope in your chat box you were able to look at the lab. Back to you, Janie.
Thanks, Annette, for sharing that out. We just wanted to circle back real quick and say why we think this is important. And it's because of these 3 big reasons of being able to reduce the harm that's within the lab, being able to have things be a little bit less costly, and having there be equity of access. So Jim pointed on this really well of not having to be as concerned with having students use these household items, and that students are able to explore a little bit more, foster that creativity, and really feel like they get to be a part of the lab and understand what's happening. Annette did a really great job of talking about too, of how showing her students the experiment and then having them figure out why that happened. And it was great to hear from Jim on how phenomenon has a place in green chemistry ed. So thanks, guys. And also just thank you everyone for joining in. I would love for you guys to put in some questions now so we can start to address them for you all. Questions for Annette and Jim would be fantastic. They are 2 really great teachers from New York. They have been doing green chemistry for a long time in their classroom, and they're really experts in this field. I also just want to extend a big thank you to New York State Pollution Prevention Institute for sponsoring this webinar and for also providing you guys with a full discount to our online course. Our online course, we have 2 courses you can take, an Intro to Green Chemistry and Advanced Green Chemistry. There are 3 credit courses that are run during this summer, but you can take at your own pace. So if you'd like to learn more about that, there's going to be a link in the chat box, and I would really encourage exploring that. It's a huge opportunity to be able to get that for a full scholarship. So big thank you to New York Pollution Prevention Institute for that. So I'm going to ask Kate if there's any questions that have come in that we'd like to go over with our panelists. And I think everyone can turn on their video cameras now so that we can all talk. And then if one person chooses to answer a question, we can then just mute our other people. Does that sound good?
That sounds great. We do have a few questions, and I was able to respond to a few folks. So here I can also say hello to everyone. So we have one great question, and I'll roll this out to both Annette and Jim, and Janie, you can even weigh in. But the question is there an experiment that you can't find a green replacement for yet?
Yes, there's Annette responding to that, and there are some labs whereby I am not able to get the same results as I would like to. So, for instance, we do a titration reaction in order to find out how much sodium hydroxide is in wood ash, and the experiment will work well if you use potassium hydrogen perthalate, the KHP, but sometimes if that doesn't work and you want to be able to get the actual concentration of the wood ash sodium hydroxide, you find that you only need the hydrochloric acid. But the way to get around that is just to use more dilute solutions and in smaller quantities. So even though sometimes the chemical itself cannot be replaced by a greener chemical, using a smaller amount is another way of greening the slab.
Thanks, Annette. And I think that this is actually a really wonderful segue. So Michael O'Brien, which Annette, you know Michael O'Brien from Siena College. He's got a great point in here, and I just love to share it out loud for everybody to also hear on the audio. And he talks about the importance of it. So it's really a comment about how it's all an iterative process, and that, again, you know, you don't need to wait until what you're doing is perfectly green, because there are so many scales. And so I appreciate Annette you weighing in on that, and Jim, I feel like you also spoke to that. But I guess, is there anything else that you want to say about your own experience of how it's been very iterative for you and how things have changed, you know, the more that you've kind of, I guess, dove in and got your hands dirty with doing green chemistry in your classrooms, what that's looked like? Jim,
Yeah,
maybe you wanna?
It's not perfect, and it's not going to be perfect right away. It is very iterative. One of the earlier things I did was replace a couple labs. Replaced the Le Chatelier's lab, so I wasn't using chromate anymore. And you just do a little bit at a time each year. Whatever time you have, replace something. You don't even have to teach the 12 principles to your students if you're not finding the time to do that. You know, you can do whatever you can on the back end, and then someday later add those things on. It's not something you're going to do all of in the first year right away. It's going to be a little bit at a time. Do what you can, dive in a little further, get sucked into all of this.
Awesome. Great, thanks. And we've got some nice thank yous. I do have a question, and we can get right back to that. Oh, geez, now it just disappeared. One is talking about sort of exams. And so I know Robert from the UK is talking about sort of his national board and exams, and for New York, you guys have regions. So yes. it'd be really applicable maybe for you to talk about how it's a state standardized test that, and how are you still able to be hitting those standards while also teaching green chemistry as well? Do you guys want to weigh in on that and what that?
Yeah, sure. So with the Regents curriculum, we have a set number of lab hours that are mandated for us to complete with the students. And then there are certain labs that we must do, and then some other labs which are maybe negotiables, which we can leave out. But what is really good is that my colleagues and I have a lab manual whereby we have about 25 of the labs that we're going to cover in there. And so that's a nice guide. In other words, so if someone had a way in which they can organize all the labs that they want to complete in a year, that's a nice sort of base to begin with. And so as you look at the labs, and you don't have to do all of them the entire year throughout, but semester by semester, as you see that the labs that are coming up, you read to see what the reaction is trying to portray. In other words, why are you doing this lab? Look at the materials that you're using, and is there a greener way to do this? And then for some of the labs that are longer and may not be able to get to, and you feel the crunch of, I didn't get a chance to green this, therefore I'm just going to do it as is. You also go back to those sets of questions that I had in my slide. Is like, why are you performing this lab? Do you have to do it? And so also weighing in. So each time questioning and checking, why is it that you're doing that lab, and is there a greener way to do it? It's just a nice platform for you to work on. And as it goes along, going with what Michael actually said, is that it's not all in one, you know, and it's not all or nothing, but it's just a process.
I found that, well, one, you're not going to get a state exam question that says, what's the 7th principle of green chemistry? That's not happening. But one of my concerns starting out with this was, do I have the time to actually teach the 12 principles to my kids and work with them on them? And once I actually started to, I found that my students loved it because my population of kids are naturally very environmentally conscious. And for them to see a way that chemistry can play a role in that is awesome, in them being more interested in chemistry. And then when I asked them about a lab I did where it might not have been the greenest version, but I thought maybe it worked better, so I went with that instead, they love telling me why I was wrong to do it that way according to the 12 principles. So it's taking the few days or however long, you don't lose that. You help get the students more interested if they're naturally that environmentally conscious. It's worked really well for me to get interest. But I started out just doing the back end things, replacing some labs, and then after a couple of years, being more upfront with the students about what the principles are, how we talk about them, and everything.
All right, there is some great, I'm trying to feverishly also respond. So this is awesome. Thank you so much for the questions and the commentary that's coming in. There is one other where Howie is asking if for taking the introduction to green chemistry course, or if you had to have taken the introduction to green chemistry course before taking the advanced green chemistry course. So I will say that it is not a prerequisite. If you have attended a green chemistry workshop in the past, whether with us, whether Siena College, and you've already started doing green chemistry with your students, then it is entirely appropriate for you to go on and take the advanced course. But if you're, in what the majority of the folks who have been on this call who identified themselves as kind of understanding and or hearing about green chemistry a little bit, but not fully understanding it, then I would recommend taking the intro course first. So thanks for that question. And we have, there was another really great question about in terms of the spectrum. So how do you assess the spectrum from green labs to moderately green to dangerous, harmful labs? And I think you guys also just kind of spoke a little bit to this as well. So hopefully that helps. And I'm not sure if there's too much more to add there. I guess the one point we did want to make is that we do have a chemical hazard assessment lesson module that is also on the website, and I have responded in the questions to all on that, where that link is. And then I have one other question here. So did you demonstrate the Lechat lab during your remote learning, which Annette, I think, yeah. And if doing the lab during school, will you let your students do it in a group? So you can take that one away.
Yes, had we been in school, the students would have been right on their own, from the making of the tea to running of the lab. So I just brought what I had in the classroom and I did it at the house. Yep.
Awesome.
Yeah.
And I just got another question, which I'm just not fast enough, fast enough to get it in and get it out. And this is about if folks who have tuned in today, if they'll get our certificate or documentation. So we will send emails with a confirmation of your attendance in the webinar at the close of this. Give us a little bit of time, but you will get a confirmation that you did attend, so that you can then share that for showing that you participated in this professional development today. And then there's also one more question about the scholarship for the summer online course. And there is a code, and I will put this in the response here, but we ask that folks would actually fill out like a little application. It's a short little application for us. And so I'll send you that link as well.
Awesome. Thanks so much, Kate, for going through all of those, being our
yeah, that was good.
Thanks, and Jim, for answering those questions. I really liked what you guys said. And so one of the last things we want to do just before we sign off with everyone is we want to launch one last poll. I know I'm poll crazy, but just asking you guys, what are the next steps you're going to take now that you've learned about green chemistry a little bit more, that you've heard from Annette and Jim, what it's like in their classrooms, now that you've heard that there's an online course, that you can do this clean sweep program, just getting a gauge from you guys of what you think. So thanks so much for filling this out. It really means a lot. It helps us gauge what you guys got and took away from this webinar. And, we would love if you guys would like to do multiple things. So that's fantastic. It seems like a good amount of you guys are interested on going to the site, to trying out different labs, to taking the online course. That's really, really great. So thank you so much, everyone, for joining us. We will be responding with those questions. We'll be getting back to you guys, and we also will have a follow-up email from us that will have the recording of this webinar, a few resources that we'll share out with you guys as well. But big thank you to Annette and Jim for being our panelists, to Kate for doing all the tech support, for really, I'm sure she's been chatting with you guys a bunch in the chat box and all those questions. It's a lot of work, so thank you, everyone. And thank you to the audience for being here, for being a part of this and joining in. Thank you, guys.